let's see if everyone's paying attention right now. Class?
Yes.
So, I know everyone's paying attention. Everyone has put their earbuds away because I've already asked them 42 times. And there's not anyone that still has their earbuds in except for the person that was allowed to, because everyone else is good students and follow directions. So I shouldn't have to tell people over and over to put them away, please. So, we're going to go through and do slope-intercept form of this equation of a line. The slope-intercept form of the equation is a non-vertical line with the slope m and y-intercept b. So we did m yesterday. M represents the slope of a line. That was the rise over the run. We have a formula just for that part right there. So we have the m, which is the number in front of the x. It's always the number in front of the x. It's not the x. So the x is not the slope. It's the number in front of the x. Thank you. Now the next one is going to be b. B is the y-intercept. So what did we say intercept is?
Y.
Yeah, where the cross is, where it touches, right? The x or the y-axis. Now that b has a location. It has a coordinate. There is a coordinate point that goes along with that. So on this coordinate right here, my b is going to be located where? What would be the coordinate of that?
-4 would be on the Y.
Yes,
Down.
but right here, just
0?
yes. So it's 0, comma b.
Oh.
That's important. That's the location of my intercept. It's always going to have a point. Yes, it says y-intercept, but that point on my graph is where I'm going to start off at. So I know you guys are writing in this notes because this is good stuff right here. So the coordinate of the b is 0, comma b. Yes? Okay, so let's go through and take a look here. So on this one it says y equals 2x minus 4. So y is the function y. We normally refer to it as either y or f of x, which is the function. Okay, they both mean the same thing. For this one right here, my slope is 2, which is always the number in front of the x, and my intercept is -4. If you notice, there is a minus sign in front of that. So the coordinate on my intercept, or where I'm going to start this at, is going to be where? 0, comma, -4. I need you to get in a habit of writing that down because this is going to be helpful over and over again. It's going to be a starting point. Yes?
I get the 0 again. Like y is 0.
Okay, so let's take a look. So this is the y-axis, isn't it? And this is the x-axis, right?
Yeah.
Okay, so it's -4. 1, 2, 3, 4. Yes?
Yeah.
So on the axis, it would be right here, wouldn't it?
Yeah.
So that coordinate, the x value is 0, and the y value is -4. So the coordinate location is always for the y-intercept is going to be 0, comma b. Whatever the b is that you have there, that's where you get that from. Does that make sense?
Yeah.
Okay, so we could write it as a coordinate. All right, anyone else? Questions, concerns, complaints? Conspiracy theories. All pigeons are fake. Yes.
Why is it 0 though?
Why is it 0?
Yeah.
Okay, so you understand that this is the axis, right? Yeah, this is the axis right here. So I'm going to, I have 1, 2, 3, -1, -2, -3, right? So is it moving left and right at all? It's not. So the coordinate, since it's not moving left and right, it's on the 0. And that's what this is right here, the 0 here. So it's 0, but if it was over 1 to the right, that would be 1, comma, -4, wouldn't it? And if it's 1 to the left, it would be -1, comma, -4. But since it's right there on the axes, it's 0. ¿Es muy bien? Michael? Yeah, go ahead. All right. So let's go ahead and take a look at this other question. So the other part of this says the slope is, number in front of the x, which is going to be 1/2. And we always read this as a fraction, which is going to be rise over run. So in this case right here, my rise is going to be
1,
and the run is
2,
now my y-intercept. The coordinate for my y-intercept here is going to be
2,
0, 2. 0, 2. We write it as a coordinate, okay? Because we put a dot on our paper and then we go graph that. Does that make sense? No? Maybe? Hopefully. All right. All right. Blah, blah, blah. All right. A lot of blah. Most people don't read these anyway, so, you know, everyone zones out when they see a lot of words like this. So would you actually, let's just go to the work, right? That'd make more sense. Graph the linear function by using the slope and the y-intercept. All right, so first, what is the y-intercept going to be? Because that's where I'm starting.
0, 2.
0, 2.
So it goes on the
0, comma 2. Now my slope is going to be, go ahead, what do we got?
rise to 1.
Yeah, 2 over 3, right? My slope is going to be 2 over 3. And the way that we read these, if we paid attention yesterday, the rise, which way can the rise go? Up and up and down, but the run is to the, it's always just to the right, because we read from left to right. So it's going to look like this. So this is going to go up and down, and this is going to the right. So rise over run. Now on the next slide, I have a graph for you. So whenever I'm graphing these, I'm going to use my starting point, and my starting point is my y-intercept. So my y-intercept was 0, 2. 0, 2, right? 0, 2. I put a dot right there. Now my rise, okay, since my slope we said was 2 over 3, right? So watch this. This is important, so when we're doing this, you can see. So it's rise 2. So I always read it as a fraction. So it goes up, 1, 2, and the run goes to which direction? Right. To the right, how many? 3. There we go. 1, 2, 3. Put a dot right there. All right. Okay, I know I suck at drawing straight lines, but you know what? Now,
So, like, were you trying to line the 2 red dots or no?
yeah, because my board's not completely lined, so when I put my marker on it, it was up. Because I gotta do that recalibration every time, and it's annoying. I hate doing that, so I just had to restart my computer. So anyway, so looking at this, what can you tell me about the slope of this line? Is this slope going to be positive or negative?
Positive.
Very good. It is going to be positive, because if I draw my little Mario guy, okay, he's climbing up that slope, isn't he? Because he's going from left to right. And since he's going from left to right, he's going up the hill, isn't he? So that's going to have a positive slope. Now this next one we have here, okay, graphing using the slope and the y-intercept. But now, what's different about this problem than my other problem? Yeah, it has a 0. Anything else? It has a 2x, a 5y, and a 0. So on my previous problem, did it have y by itself?
Yeah.
Yes, it had it as y equals. And so what we need to do here, we're going to do a little bit of algebra to make this into y equals first. Yeah, I'll watch it. Yeah, I'm going to go there. So we have 2x plus 5y equals 0. And I said I want to get my y by itself, don't I? I wanted to say y equals, so I want to get that by itself. So I got to get rid of my 2x. So my 2x is on the left-hand side. I don't want it over there. I want it on the right-hand side. So what am I going to do there? Very good. Very good. Subtract it from both sides. So 5y equals negative 2x. Now, what is happening to my y here? It's multiplying right now, right? The 5 and the y are multiplying, and the opposite of multiplication is? Very good. Divide, division. So I'm going to divide both sides of my equation here by? There we go, 5. So y equals negative 2 over 5x. Uh-oh. I'm missing something here. The y-intercept, right? The y-intercept. Is there a y-intercept there?
Yes.
Yes and no. What number do I use for the b? 0. It's going to be 0. There's nothing there, is there? Because it's always supposed to be y equals mx plus b, but if you notice, I don't have a b over here. There's nothing over there. So I need to imply, since nothing is there, that it is going to be plus 0. So my slope is going to be what? Negative 2 over 5. And my intercept point is going to be? Say the whole thing. The point? 0, 0. So that's going to be at the origin, 0, 0. Easy? Yeah. ¿Está muy fácil? Sí, muy fácil. All right. So let's go to the next page, and I did not put a graph on this one for some reason. So I will, and you will, make sure you have your own amazing graph on yours. All right, so here's my amazing graph. So where am I going to start my graph? Graphing my line here. 0, 0, right? So I'm going to start this here at 0, 0. So let's go ahead and I'm going to put a dot at 0, 0. And my slope? Now, what is that negative 2 going to do? It doesn't go back, it goes down. Very good. It goes down because the run is always to the, it's always to the right. Run to the right. So this is going to go down 2. Let's go down 2. So 1, 2. And my run is to the right 5, isn't it?
Yeah.
Okay, very good. So 1, 2, 3, 4, 5. Now, draw your little Mario on this one, mentally. You don't have to, actually draw it out. Can you tell me, is this going to be a positive or a negative slope?
Negative.
Because it's decreasing. It's going down, isn't it? Okay, very good. So what I'm going to do is I'm going to stop right here. I'm going to pause this. I'm going to give you some time. We're going to start on the homework. And then we're going to pick this up again and finish the last 2 examples here. Is it 2 or 3? I think it's 2. All right, so pause. All right, so back again. Class?
Yes.
All right, we're going to finish up these notes, and I know everyone's going to pay attention and follow their notes because that's what good students do. That's what good students do.
Check it.
I told you I will in a minute. Finish your notes.
I'm done with my notes.
All right, so we're going to graph this right here. This says y equals negative 4. So horizontal line. We're graphing a horizontal line. So now everyone, with your hand, show me a horizontal line. Show me a horizontal line. Yes. Yes, yes, yes. No. Yes, yes, yes. Horizontal line. Yes. Really? No, perpendicular. Yes. All right, who else? Yes, there we go. That's parallel.
I know.
What? That's a circle. Huh? This is not YMCA. Come on. A straight, flat line is a horizontal line. You're like that 80s song, trying to walk like an Egyptian. And I know I said yes, but he's look at this. What's he doing? I don't know. All right. So what we're going to do, this is going to be a flat line. Okay? It's flat. So if I have my little Mario, okay. So, is he rising at all? He's not rising. But he is running, isn't he? So he's running to the, so my rise over run, my rise is 0, and my run is whatever that number is. So it's not going up and down, is it? But it is going to the right. So by doing that, there's certain things I'm always going to know. So no matter what I have for my x value, my rise is going to be what?
Your rise is gonna be 0.
It's going to be 0, right? It's not going to go up at all.
Yeah.
My rise is always going to be 0. So if my x value, let's see, my x value is -2, 0, and 2. So let's plug that in and evaluate for this. I'm evaluating for this right here. Where am I going to plug the x in at?
-4.
Nope, try again. Huh?
X, you just put the X.
Is there an x there?
No.
There's nowhere to put the x. So when I plug it in, if there's nowhere to put an x because there is no x, my answer, y, is always going to be what?
0.
-4. So no matter what the x is, because if I plug it in, there's nowhere to plug it in at. The y is equal to -4. So if this is -2, the y is -4. If my x is 0, my y is? If my x is 2, my y is? So no matter what, it's always going to be -4. So we're going to plot these 3 points here. We're going to plot these 3 points, and this is always for horizontal lines, especially for people trying to text underneath their desks, asking like there isn't, like something blocking that I can't see them, both hands underneath their desk trying to text. Yeah, So, I know you wrote this down because you weren't texting. So my points that I'm going to use is -2, -4, 0, -4,
Vertical line.
2, -4. So -2, -4. Put a dot right there. 0, -4. Put a dot right there. 2, -4. Put a dot right there. And between those lines right there,
So vertical.
really close, really close. That one's a good one right there. Okay.
This is better than the other, like, on the line. Like,
I know it's actually on the line this time. So right here, all 3 of those are on that same line. So this is a
Vertical line.
horizontal line. What's the slope on this one? Is it going up and down? No, my slope is 0. My slope is 0. So there is no slope. There is no incline, there is no decline.
Yeah, cool. Maybe.
Now, we're going to do this again, but this time it's going to be x equals 2. Now, vertical. Vertical. Now, with your hand, show me a vertical line. Show me that vertical. Yes, 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 yes. Why do you got to play? Yes, yes, no, yeah, yes, yes, yes. It's good, right? It's good. Both, good, yes, yes, yes. Now, we're going to go through, and it's going to be like Mario. So I have my Mario. So there is that vertical line right there. So what can you tell me about Mario when he comes up to that vertical line?
He's gonna be stopped. He's gonna get stopped.
Is he still going to be able to run? He's not going to have any run, is he? No run. So my run has to be 0. My run is going to be 0. Because Mario comes up to a wall, he can't go any further, right?
Yeah.
And so that means he's only going to go up or down. So I know that my run, so it's going to be my rise over 0. Because it's not going to run at all. And if I'm paying attention, it says x equals -2. So what do you think my x equals right here? 2. 2. Okay, what do you think this next x is?
2.
And what do you think the next one is? 2. They're always 2. X is always 2. No matter what my y is, x will always be 2. So I can make up stuff for my y and it's not going to change because if you notice there's no y here, is there? There's no y to plug into, so I could have -2, 0, and 2. Because we know x is always 2. So I'm going to do that. Now I'm going to graph those points. All right, so 2, -2, 2, 0, and 2, 2. And now, what am I going to do with those right there? What am I going to do with those 3 dots?
You draw a line in with it.
Yeah, draw a line. Draw your straight line up and down. Ah, that went not so well.
Yeah. Let's straighten it out.
Now, the slope of this one right here, going straight up and down, can I divide by 0? Right here when it's rise over 0, can I divide by 0? Can I divide by 0? Say no. No, you cannot divide by 0. You cannot divide by 0. You cannot have 0 in the bottom of one of these fractions. Anyone know that special word? It is? What is it when you have 0 in the bottom?
What is that with?
It's just
What's the word start with?
No.
No, what does the word start with?
Starts with ends with defined. Hey, it's undefined. Yes, very good. It is undefined. Those ones are going to be undefined. So when I have 0 in the bottom of a function, or a fraction right there like that, it's going to be undefined. So when I look at this and I say my slope, so this slope here is undefined. Does that make sense? Yes.
That's only when the bottom of the fraction is 0.
Yep, bottom of the fraction 0. So if you have to look at, if someone gives you a graph and say, hey, what's the slope of this one? What's the slope? You're going to say it's undefined. And what's the slope of this one here? What do we say the slope of this one? 0. The slope is 0. Because it has no rise, but all run. All right, so there it is right there. Blah, 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 blah. There. Blah, 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 as rates of change. Okay, now, we use rates of change all the time for all kinds of stuff. You guys probably don't realize it, but that's majority of the math. Like this morning when you're speeding through the parking lot. So the speed limit is 15 miles per hour. So the rate of change is 15 miles per hour. So that's, if you're going that fast in 1 hour, how far would you go? 15 miles. So that's 15 miles per hour. That is a rate of change. Okay, stuff like that. If you go to the, go to the grocery store, hamburger is $2.99 per pound. That's the rate of change, how much it is per unit. Okay, so we're going to go ahead and in 2016, college freshmen were more politically polarized than they have been in the last 36 years. The line graph, next slide, shows percentage of college freshmen who were liberal or conservative in 1980 and in 2016. Find the slope of the line segment represent liberal college freshmen. Round 1 decimal place. Describe what the slope represents. So, let's take a look. It's going to look like this. So the formula is delta y over delta x. This is the same thing that we did with that other formula, y2 minus y1 over x2 minus x1. So it's a change in y's divided by the change in x's. The change in y's divided by the change in x's. The change in y's divided by the change in x's, right? Actually, I love to interrupt you. So the formula that goes along with this is going to be y2 minus y1 over x2 minus x1. So this point right here is going to be x2, y2. This first one right here is x1, y1. We're going to do the blue one here in a second on the other side. So from here, we're going to start plugging in my numbers. So y from the second. What's y from the second?
19? No, 22
22 minus y from the first
19.
over x from the second
1980. Oh, no, 2067.
minus y from the first.
1980.
And go ahead, do the math for me, please. Where'd the notes go?
Did we get this already?
Yesterday.
Oh, okay. No, I got it.
Okay. Come on. You just saw me yelling at him for something stupid. Okay, so what do we come up with? 3 over 36. Does that reduce?
Yes.
Yeah.
It reduces to what? 1 over 12. Now the rate of change, now, the top, what was the top talking about?
I was talking about the freshmen. Percentage of freshmen.
Okay, percentage, so it's a rise. Is it increase or decrease?
Increase.
It's an increase because it's positive, right?
Yeah.
So it's an increase over
The years of the
years, right? So it's 1/12 increase over years. That's my rate of change there. Now we're going to do the same thing again, but this time we're going to do the blue one. So again, my delta y, delta x. So we're using the same formula. Let's go ahead and take a look. So when I said do these, we have to label them first. So if I'm labeling this as x1, y1, this one is x2, y2. So I would like for you people right now at this current moment in time, I want you to do this one. the blue one, just like I did over there on the red. You know I grade these notes, right? And you know yours are empty, right?
Wrong. They're all done, see?
What did I just ask you to do? Hey, I just asked you to do this.
Yeah, I know.
Please do it.
I will.
Please do it right now.
After you do it.
Right, so listen to notes.
Is the packet permission?
Yeah, so two. Okay. Yeah, do this one. Do that one. That's one. There it is. Yep, and what's my rate though? Increase per year, right?
Today's Wednesday, huh? Gotta go home early.
Not completely. You could reduce the fraction. Make it to a simpler fraction. It's right here. Yes. Yes. It's this exact same thing. This exact same thing. The exact same thing. You. Good job. Okay, yes, reduce the fraction though. You can reduce that. Yeah, it's a fraction, reduce it to a smaller fraction. So, if we go through and do this, we come up with,
5/12.
okay, so it came out like 15, right?
Yeah.
Over, and reducing that by a factor of 3 gives me 5/12. And from there, 5/12. And now I have to label it. By rate of change, it's changing what?
5%.
Yeah, 5/12 increase
Mr. Pacho,
every year.
why did I get 5/18?
Cause you might have did your math wrong.
How?
I didn't see anything on your paper, so that.
Isn't 63.1 and then 36, 83.6? Oh no, that's right.
No.
That's 3.2, 3.4. Yeah.
Okay. All right, there we go. And there we go. So don't forget, I would like for you guys to like, share, and subscribe. Hit that notification button and buy something. Support my channel. Buy stuff from my merch store.